All right, let's suppose I want to solve this equation. So solve. Number one, let's suppose I have the log base 3 of x plus 5 equals, let's say, 5. I want to solve this equation. So I want to find out what value of x, when I substitute that into the argument, I take the log of that base 3, what value of x will make the left side equal to 5? That's what I'm interested in. All right, now you really, all of you have enough information based on what we did in the last 2 days with logarithms to be able to figure out how to find the value of x. Now those of you that just did it, don't answer this question, but the rest of you, if you were given this right now, let's suppose you had a pop quiz and you were given this equation, how would you solve for x? I'm sorry, say it again?
X plus 5 equals 5.
Nope.
So x plus 5 equals 0.
Nope.
Greater than? X plus 5 is greater than 5?
Nope.
I have no idea then.
When they run out of
Oh, no. I did it wrong.
All right, so you saw yesterday how to write a log equation as an exponential. Not one person connected that. How do you write a log equation as an exponential? How would you write that as an exponential? All right, guys, you have some work to do, right? Okay, even though before you left yesterday, you turned in a worksheet that had this on it, or this idea on it. Okay? 3 to the 5th equals what? X plus 5. The base is 3 to the 5th power equals the argument. There's your equation. You went from this log equation to a linear equation. So you need to change this log equation to what kind of equation? An exponential equation. Now in your calculator, what's 3 to the 5th? What's 81 times 3? 3 to the 5th. What's 3 to the 5th, guys? What is it, 343? 243? Okay. So 243 equals x plus 5, and so what's x? How do you get x by itself? And so x equal 237, is that correct? 238? So there's x, 238. So your solution is 238. So if you were to plug in 238 into the original problem and take the log base 3 of that, that's equal 5. Now let's go ahead and check it, although we haven't talked about this, but let's go ahead and talk about it now so that you can check this. So here's how you check this. Just like with any equation, you take this value, plug it back in, right? So let's check it. So it'll be the log of 238 plus 5 base 3, and I want to see that's equal to what? 5. All right, what's 238 plus 5? 243? All right, so I want to see, is this side equal to 5? Now, there are 2 ways you could do this, okay? You could change this back to an exponential. 3 to the 5th better equal what? 243. All right, so check in your calculator. What's 3 to the 5th? What's 3 to the 5th in your calculator? 243. So it's correct. Now here's the other one I want to talk about is this. On your calculator, what bases does your calculator use? Base 10. Base 10, and what are the base? Base E. Those are the only two bases your calculator uses. So anytime you use your calculator, you take the log of 5, the log of 2.7, the natural log of 6, the natural log of 8.2, because those are the only two log functions on your calculator. The only bases you're dealing with are base 10 and base e. Common logarithm and a what? Natural logarithm. But that's not one of those bases. What's that base right there? Base 3. So suppose I asked you, and I said, what is the value of this? Log of 8 base 3. And then let's round to 4 decimal places. Now, all of you will probably try what you did yesterday. You would say 3 to the box equal what? 8. But there is no whole number. There is no whole number that will make this work. Because 3 to the first is 3, 3 to the second is 9, right? But log of 8 base 3 is equal to something. All right, so here's how you do that. Huh? Okay, so here's how you do that. You're going to use what's called the base change formula. All right, base change formula. And the base change formula is very straightforward. So if I have the log of a base b, the log of a base b, and I don't want the base to be this b, but I want it to be something else, let's say. Let's say I want the base to be c, okay? I want the base to be c. Then all you do is this. Now there's a derivation of why this is true, but we don't have the time for that, so just believe me. So if I want to change this to base c, then I would say the log of the argument, which is a, with my new base. What's my new base? C. Divided by the log of the base, the old base. What's the old base? With my new base, and what's my new base? C. So that's the base change formula. The log of a base b is the log of a with my new base divided by the log of b with my new base. Okay? Now watch how simple this is. Let's go back over here. If I want to use my calculator, then what base might I want to use? Huh? I'm sorry, I can't hear you. 10. Or what other base? E. Because those are the only two bases your calculator has, log and ln. Log is your common logarithm. What's that base understood to be? 10. Ln is the natural logarithm. What's that base understood to be? E. Those are the only two bases I can use with my calculator. So I'm going to do both of them. So if I want to use base 10, then I got to use this formula. So I'm going to say this is going to be the log of 8. Now remember, if I don't have a base, what's that understood to be? 10. Divided by, and then what do I write down here? Log of what?
3.
3. That's my base change formula. So on your calculator, you're going to say the log of 8. Now, when you press the log, it automatically puts a parentheses. So you got to close it. Divide by the log of 3, and then press equal. What do you get?
1.224.
1.224? All right,
All right, let me try
I'm
this.
just, let me go ahead and do it myself then.
Divide the log of 3. Okay, I got that. Now I got 1.892, or 1.893.
All right, so the log of 8, so log of 8 divided by the log of 3 equal, so 1.8928.
I didn't put one more parentheses.
All right, okay? So that's what that's equal to. Now, that's not, someone said it will be a fraction. No, because that's an irrational number, it's not a rational number. So there's no way you can write an irrational number as a fraction. Okay?
Okay, so what do you do?
All right, so the exact answer is this, right here, but we approximated, and that's how we approximate it. And you can approximate so many digits. I just asked you to approximate to 4 decimal places. All right, let's use the natural log. Now I'm going to ask you this: if I change the base to base e, what's this answer going to be? Will it be different? Will it be the same? No, don't do what you said. Answer the question. If I change the base to base e instead of base 10, will this be the same thing? How can it be different? Listen to me. How can it be different when I'm asking to evaluate this expression right here? How can you have different answers? It's kind of like you telling me that 1/2 is equal to something else than 0.5. Now you might say, well, in terms of a decimal, you could say, well, what about 0.50, 0.500? Well, yeah, I mean, they're all equivalent, but you can't tell me that 1/2 is 0.8, right? 1/2 is just the decimal 0.5. The same thing here. The log of 8 base 3, there's just one value for it. So if I change my base, so instead of log, I use natural log. So the natural log of 8 divided by what?
Natural log of 3.
Natural log of 3. Use your calculator, tell me what you get.
Same answer.
You get the same thing. It does not matter what base you change it to. The base change formula says it doesn't matter what base you change it to, you'll get the same value. The base change formula is very helpful to you because your calculator only uses what bases? 10 and E. Okay? So when I went back to this one here, right here, and I want you to check this using the base change formula. Check it using the base change formula. So the log of 243 divided by the log of what? The log of 243 divided by the log of what? The log of 243 divided by the log of what? 3. Why is it taking us so long to do the log of 3? You'll get 5? Okay, you get 5. Okay? All right, number 2. Let's solve this one. Okay, suppose you had the log of 2 of 3x minus 4 equal, let's say, 3. Now you're going to solve this equation. You now know how to solve this equation on Monday. What are you going to do? What are you going to do Monday? Leave it blank? Change it to exponential. So what is this an exponential?
2 to the third power
2 to the third.
equals 3x minus 4.
And now it's 2 to the third.
8.
So I get 8 equals 3x minus 4. And then just solve for x. What's the next step?
4 both sides.
Add 4 to both sides. So I get 12 equals 3x. So what's x?
Divided by 3 is 4.
X is 4. So there's your solution. So X is 4. And you can check it, and we can check it using the base change formula. So let's check it. The one in your test you can check very easily. It will look like this. So if X is 4, what's 3 times 4? 12 minus 4? 8. So I have the log of 8 base 2. Now that one's straightforward because 2 to what number is 8? 3. But let's use the base change formula. So it's the natural log of 8 divided by the natural log of what? 2. Or you could have just said the log of 8 divided by the log of 2. Do you get 3? You get 3. All right, which is what this was. Okay, so any questions on solving an equation? That's all it is. Now the one on your final, though, is a little bit more complicated than this. So we're going to do that part Tuesday. The one in your final comes from section 4.4. All right, now let's review a couple other things. Okay, suppose you want to suppose you want to convert each exponential to an equivalent log equation. All right, so you would convert each exponential to an equivalent log equation. All right. Almost all of this you had yesterday before you left. You had to turn in some stuff yesterday. Almost all of what we're about to do is that idea in terms of review. All right. So let's look at number 1. Suppose we had 7 to the 4th power equal x. How do you convert that to a log equation? Okay, so you're going to write log, L-O-G, with an equal sign. What's going to be the base? 7, right? So 7's your base. Now, guys, there were a couple of you that I got on for the way you were writing your equations, your log equations. So watch what I'm going to tell you. All right, so 7 to what power? So what's my power? 4. So the argument has to be x. It has to be this. All right, so when you write it, I want you to notice that the LOG and the x are on the same line. Okay? So some of you are doing this. Some of you were saying 4 equals the log of 7 like this with an x. That's not how you're supposed to write. I'm sorry. With a 7 and an x like that. All right. It's got to be level, the LOG and the argument. The LOG and the argument have to be level. Okay? So do the best you can with writing that 7 as a subscript. All right. So 4 equals LOG x are on that same line. Okay? All right. So that one was from yesterday. Number 2, suppose we had e to the 5th power equal x. E to the 5th power equal x. All right, now we're going to write it just like we did the previous one. So we're going to say LOG for right now. Okay, LOG. So I'm going to have LOG equal sign. All right, what's my base? E. So E, subscript, E raised to what power? And what's my argument? X. All right, now, don't leave your answer like this, though, because you know that if the base is E, then we can rewrite the log base e using what notation?
LN.
ln.
Oh, that's what I thought it was gonna be at first.
All right, ln. So your answer is just going to be 5 equals the natural log of what? X. That's the answer you write. Okay? So whenever the base is e, you're not going to leave your answer as log base e. You're going to write your answer using natural logarithm. Okay? So just remember that. Number 3, suppose I had this. 10 to the x power equal 5. 10 to the x power equal 5. All right, so you're going to write log for right now. Now you can skip that step if you know how to proceed to the answer. All right, but a few of you may want to write this step. So log, what's the base? 10. Equal, so 10 to what power? What goes here? X. And what's my argument? 5. All right. Okay, now you got to, don't say that's the answer. Don't put that in the blank because I'm not going to accept it. Because I need for you to understand that log base 10 is what logarithm? I want you to say common logarithm. That's your common logarithm. So just going to be log, right? So this right here is just x equal log of 5. That's all that is. So there's no base there. It's understood to be what? 10. If the base is e, you're going to rewrite it using what logarithm? ln. Okay. All right. Now let's look at this one. All right. The next part, let's convert each of the file. Oh, sorry. Let's convert each exponential. I'm sorry, each logarithm to an exponential. Okay, so suppose I had this. Suppose I had, number 1, the natural log of x equal 5. The natural log of x equal 5. And I want you to convert that to an exponential. You got to remember, ln has what base? E. So in your mind, you're thinking of this right here. You're thinking of this as log with what base? E. That's what you're thinking about. And now you can tell me what that exponential equation is. You're going to say what?
E to the 5th.
E to the 5th equals x. E to the 5th equals x. So your answer? E to the 5th equals x. And if you had this, the log of, let's say log of 7, that's a 7, equal x. Log of 7 equal x.
10 to the x power.
So log with no base listed is understood to be base 10. That's your common logarithm. The one we just did was a natural logarithm. Natural logarithm has what base? E. Common logarithm has what base? 10. All right, so you would say 10 to what power?
X.
X equal 7. Okay. All right, now let's simplify. So he's going to say evaluate. Number 1. All right, suppose I had the log of 10,000. The log of 10,000 without using a calculator. Without using a calculator. Just like you did yesterday, how would you determine the log of 10,000?
10.
So you first of all write it as, it'll have equal blank, by the
10
way.
box equals 10,000.
So look, it'll have this. So then you would say, oh, I remember that. I just got to change this to an exponential. So remember, that's where we said 10, because the log, there's no basis understood to be a 10. So you'd say 10 to the box equal what?
10,000.
10,000. Well, 10 to what power is 10,000? 4. 10 to the fourth power is 10,000. So the answer is 4. Number 2. What about the natural log? Let's do this. What about the log of 1? No calculator. What about the log of 1? Equal blank.
0.
Yeah, because we know that means 10 to the box equal 1. Well, 10 to what power is 1? 0. Answer is 0. All right, what if you had this? The log of 1 over 10 to the third power. The log of 1 over 10 to the third power. Now that gets some students right there. So before we do that one, before we do this one, let me go back and do number 4. Suppose I had this. The log of 10 to the 8th power. Log of 10 to the 8th power. Remember from yesterday how you did this? So then it was going to equal blank. And so your base is understood to be what? 10. So you change it to an exponential. So you remember that right here is understood to be a 10 right here. So you said 10 to the box equal, the argument, what's the argument?
10 to the 8th.
10 to the 8th. Well, on the last test, you knew that if the bases are the same, then what else has to be true? Exponent. So what's the box?
8.
8. So let's look at this number 3 now. It doesn't quite look like number 4. Because in number 4, I have 10 to the 8th. But in number 3, I have what?
10 to the
No. What do you see? 1 over 10 to the third. That's what you see. But you know enough information based on your previous courses and what we've done in here to know that I can rewrite 1 over 10 to the third to something that looks like this. You know how to do that? I guess we have to do what we did yesterday again. What is 3 to the negative second power equal to? 1 over 3 squared, right? So I'm asking you, do you understand that 1 over 3 squared is the same thing as 3 to the negative second? Do you understand that 1 over 8 to the 5th power is 8 to what power? Negative 5th? Do you understand that 1 over x to the negative second power is x to the second power is x to the negative second power? So therefore, what is 1 over 10 to the third the same as? 10 to the negative third. So this right here is the log of 10 to the negative third. And now that looks like number 4. So you say the base, what's the base right here understood to be? 10. So 10 to the box equals the argument. What's the argument?
10 to the negative third.
10 to the negative third. So therefore, what's the box equal to?
Negative third.
Negative 3. Negative 3. All right, and then we also saw some properties yesterday. Yesterday we saw this, that if we have, number 4, that we have, let's say, 7 to the log base 7 of x, what's that equal to?
X.
That's equal to x. Whenever the bases are the same, it's just the argument. Number 5, if I have, let's see, if I have, all right, if I have this, the log of 7, log base 7 of 7 to the 4x power. Based on what we did yesterday, what's that equal to? 4x. It kind of makes sense still because I can change this right here to an exponential. 7 to the box equals 7 to the 4x. So what must the box equal? 4x. All right, and then what about this? Number 6. What if we had 6 to the log base 6 of the square root of x? Whenever the base is the same, it's just the what?
Square root of x.
The argument. So what's the argument?
Square root of x.
Square root of x. That's all you do. All right. So that was a quick review on what we did yesterday and something that you're going to need for Monday. All right. So